Welcome back, everybody. We're going to finish off this section of implicit differentiation with a couple of additional examples, and in these we're actually going to find the equation of a tangent line to various points on this curve. We're told we want to find the equation of the tangent line to this curve. We have the picture of it here, and the equation is x plus y cubed minus y equals 1. Those of you who were here with me on Friday morning, you recognize this equation and the graph. We examined it already, and in class, as our warm-up problem, we actually found the 3 points that are already that we can see in the graph now. When x equals 1, we have the point 1, 1. We have the point 1, 0. And there's the point 1, negative 1. And you notice they all three have different slopes, so there's going to be 3 different tangent lines. One looks like it's got a pretty shallow negative slope. One's got a positive slope. This one's got another negative slope. Okay, so we're going to be finding the slopes of the 3 tangent lines and then the equation of the 3 tangent lines. Well, that means we find our derivative, and this equation is not a function of x. It cannot be solved y equals in explicit form. We have to leave it in implicit form. The implicit part is that we assume that y is a function of x, and so anytime I'm coming to find the derivative of something like y cubed, you think of it as the function f of x cubed. So if I need the derivative of this, it's going to require the chain rule. We'll see that as we go through. So we're going to apply the derivative notation, derivative operation, to the entire left side. And the derivative with respect to x also on the right side. And on the right side, the derivative with respect to x of that constant will be 0. On the left, the derivative of 1x will be 1. The derivative of y cubed, here's where you think of it as a function cubed, and this is the chain rule, where the cubed function is the outer function and the function f of x is the inner function. So my chain rule would require the power rule apply first, 3 times that function squared, then multiply by the derivative of the function. We'll just call that y prime. And then over here, this is like saying what's the derivative of f of x? And the derivative of f of x is f prime of x. We will call that y prime. And so there is my differentiated equation, but I like to get it solved for y prime now. And since 2 of the 3 terms contain y prime, we're just going to subtract 1 to the other side and leave everything here. That contains y prime. I'm going to factor out the y prime. And don't forget to leave minus 1 here equals negative 1. So my derivative y prime is negative 1 over the quantity 3y squared minus 1. So I'm just going to circle that, even though that's not the ultimate thing I wanted to have here, but it's an important piece. So now we want to work out the slopes next. Okay, so I'm going to take the first ordered pair, 1, 1, and in that case, my derivative is, or my slope is negative 1 over 3 times y squared. So notice this derivative only requires we know the y coordinate. So that's going to be 1. And 3 times y squared would be 3 times 1. And so ultimately my slope is negative 1/2. If I'm at the point 1, 0, my slope is negative 1 over 3 times 0 minus 1. And therefore my slope is negative 1 over negative 1, which is positive 1. And if I'm at the point 1, negative 1. Quick look at that derivative and notice that the only y in here is squared, so this is going to produce the same exact result as the 1, 1. So y prime is negative 1 over 3 minus 1, and that is going to be negative a half. First thing I'm going to check is that do the positives and negatives of slopes seem to agree with the drawing, and it definitely does. And so what's left for us to do is write the equations of the tangent lines. And so let me actually just move this over a little bit so we have room to write the equations right beside it. So we'll just do point slope form. This is going to be y minus y1, so y minus 1 equals negative a half times x minus 1. This one will be y minus 0 equals 1 times x minus 1. And this is going to be y plus 1 equals negative 1/2 x minus 1, and there it is.